Am I audible over the web? Okay. I've not uploaded the notes, is it? Okay. Okay, sir. So let us basically get started. Let us try to understand this concept of containers. And container is the most important area because that is where most of the applications are getting deployed. Okay. So before we define this term called as container, let us try to understand before containers what used to happen, so that we'll get some context about containers. Okay. So let me try to take this sample application architecture. Okay, we'll be refining this. Right. So let us assume that this is a which application should I take? Okay. So let me try to take it as a school or a college management system. Yeah. So because all of us have gone through education, I'm quite sure that in your college they might be using some software for managing all of your records and all that stuff, right? So now let us assume that I'm speaking about this architecture and how it used to be. The first thing is, generally the architectures were plain, simple, straightforward earlier. Okay, right. So right, we used to have application server. Application server is something which will try to learn, which will try to run web applications which are designed in programming languages like Java, .NET, Python, or whatever it is. And on top of this is your, let me call the product's name as LTCMS. LTCMS is LT College Management System. Let us assume that this is what it is. And this package is something which you use to deploy on an application server. Okay. So for example, if I have to give some examples over here, if my application is developed in Java, so this LTCMS application server would have been something like Tomcat or WebSphere or WebLogic. These kind of servers used to run Java-based applications. Okay. And if it was .NET, it would have been IIS server. So we have a server, and then this is where your application runs. But only application will not solve our problem. So for that reason, we used to have a database engine. So this could be any database. It could be MySQL, Postgres, Microsoft SQL Server, Oracle Server, whatever it is. On top of which, you would have your applications database. So this application, okay, will speak with the database, and whoever users are using in your college, they would use a Chrome applications on their laptops. By typing some IP address or a name, the request used to go to the server, and this server used to store everything in the database if it has to do something with respect to storage. Are we clear on this? Yeah. So this is a simple college management system. And how many servers are we speaking about? Two servers. One is an application server, the other one is a database. So again, this could be a Java application, this could be a .NET application, Python application. I'm not worried about technology. For now, if you want, if you want to make assumptions, I can try to call this as Java application and this database as MySQL database. Okay, because I have to give something, but I can replace that with any technology. Are we clear on this so far? Yeah, right. So let us assume that this is something which your organization or which your college or school is using right now. Okay, fine, sir. Let me basically save this. Okay, right. So right, overview. So what is it I'm trying to tell? This application has a database. For our assumptions, I'm calling it as MySQL database. This application is developed on, let me try to call it as Java, and it needs Tomcat server, Tomcat or WebLogic or WebSphere. You can run it on any of this server to run the application. Straight away, simple. Yeah. So users access the application, okay, over the browser. Let it be any browser, they access the application. So as a user, I try to access some URL, I'll get a login page, I'll enter my username and details. If I'm a librarian, so then I'll have all the things related to library where I can give books, add books and all that stuff. If I'm a accounting person, then I'll have something to do with accounting where I basically speak about all the fees collected, expenses that have been spent. I'll have all of this application. Now, if you try to look at this architecture, okay, this architecture is also referred as monolith. What is it, sir? Monolith. Monolith basically means that all of your application is running from one server. In this case, all of our application is running on application server. Yeah, database is different, but I am speaking about application, not a database. ఇలాంటి అప్లికేషన్లు ఏమంటాం? Monoliths, right? Because we need to understand monoliths as well as microservices going down the line, right? Fine. Now, the deployment of this, okay, in the first generation, okay, right? Or let me try to add more context, okay? We are working for a, so let us assume that I'll try to speak about. We are working for a software company, sir, who develops this application and deploys it in multiple colleges. So we sell the software and we deploy it into the college, okay? And then we basically run this application. What are the options of running this application? Let us assume that I am trying to speak about a first generation case. In first generation case, okay, is on physical servers. So what I would try to do is, I'll try to go to your college lab, and in your college, I'll be asking two servers, right? Yeah. So what is it I've done? I've asked for 2 servers, and obviously these servers will be connected from all of your organizational systems, and then they can ping with its IP address, because whenever your organizational server is connected, or in your college, if you basically try to create a server, or once it is connected to your network, then it will get an IP address. Do you agree with me on this? Yeah. So in your organization, generally for these kind of things, we have Ethernet cabling, and that Ethernet cable is plugged into your server. So this server gets an IP address, and this server gets an ఇంతే కదా, రైట్? మీ కాలేజ్ ల్యాబ్ లో ఏమైతే సర్వర్ సిస్టమ్ ఉన్నాయో అన్నిటికీ ఇలా ఈథర్నెట్ కేబుల్ ఒకటి ఉంటుందిగా. आपके कॉलेज के लैब में जो भी सर्वर्स थे वो सबको ईथरनेट कनेक्शन, वायर्ड कनेक्शन हुआ होगा. That is exactly what I am trying to represent. And let us assume that this is placed in some room with air conditioning, because we are speaking about a decent size server. Now on this I have to take an operating system. So let us assume that I have taken a Linux operating system, that is Red Hat Linux, or let me try to take Ubuntu, because my college doesn't want to pay a subscription fee. Okay. So I've taken 2 operating systems, 2 Linux operating systems, which is Ubuntu Linux. Ubuntu is free of cost, and my organization has taken this. Right. Now I have to run this server. So what do you think I should do? I have to run 2 components, in which I have, one is I need this, the second one is I need a database. What is my intention over here, sir? నా ఉద్దేశం ఏంటి? ఈ అప్లికేషన్ మీ కాలేజ్ వాళ్ళకి డిప్లాయ్ చేయడం, so that everyone has to use application. For running the application, I need servers. So I have made your college buy 2 servers. Okay, right, sir? So now over here, what I said is our application will typically need approximately around a server of 4 virtual CPUs and 16 GB of RAM. This is what I have said to your college. Will your college exactly buy 4 virtual CPUs and 16 GB of RAM, or they go with a little bit extra? Why they go with little bit extra? Because in the future, if this is not enough, at least that extra space can accommodate. So I've asked for 4 virtual CPUs, they have given me 8 virtual CPUs. I have asked for 16 GB of RAM, they have given me 32 GB. Okay. Now on this I have installed an operating system. So this is the OS component, right? On top of OS, what they have done over here is, since this is a Java based application, they have installed Java. And then I said that I need some application server. So let me take Tomcat logo, because Tomcat's logo looks good. That's it. Yeah. But I can use any WebLogic, WebSphere, or any of that stuff. Okay. All right, sir. Now on top of this, they have installed Tomcat. Tomcat also uses Java that you have installed on your machine. And then on top of it, they have taken our application. Generally, Java applications on this world will have an extension which is called as WAR. A file package extension WAR on it. Okay. So I've deployed the WAR file. And this WAR file will start working when we have a database. So what is it I have done? I will be installing MySQL database. And I have basically taken a help from a DBA who has created LTCMS database. Am I clear on this? Okay. So where do these servers belong now? In your college. They are in your college, purchased by your college. Before running your application, we have basically given them the hardware specification, and they have bought it. Now, generally when you're any teaching or non-teaching employee of a college connects to a college's network, from their laptops, they can access this application. This was my deployment scenario. Okay, right, sir. So let me try to write it down. This is my network. Okay, so probably on my in my organization, I have a Wi-Fi router, which is again connected to the same network, and these devices are connected using Wi-Fi. So now are all of them present in the same network? All the devices in the same network can communicate freely. So we don't have any networking problem. Application is working perfectly. Okay. Right, sir. Is there any problem so far? Okay. So right. Okay. Now, what was the CPU which I said I want? 4 virtual CPUs and 16 GB of RAM. What did college give me? 8 virtual CPUs and 32 GB of RAM. But actually, when the number of users were using my system, what has happened is here it was using somewhere around 2 virtual CPUs and 4 GB of RAM was enough. నేను అడగడం 4 అడిగాను, ఎందుకన్నా మంచిదని. వాళ్ళు నాకు 8 ఇచ్చారు. ఆఖరికి వాడుతున్నాయి ఎంత? 2. Is that okay? So I asked for 4. They gave me 8. But ideally, what is it I'm using now? 2 virtual CPUs, right? So for your college, was it not extra unnecessary waste of money? Because to buy a 8 GB 8 virtual CPU server, it is very costly affair. Okay. Now, if you are trying to speak about one college, if this is a scenario, try to consider that I am speaking about a college where they have chain of colleges like VIT college. In VIT throughout India, they have many branches, and I'm selling the software over to them. Now, for them, is that okay? Yeah. So for one college, 2 virtual CPUs, you have 10 branches. Now I want 20 virtual CPUs. This doesn't work out, right? Yeah. So what do you think we should do? This was the first generation where we used to deploy everything on physical servers. So far, are we clear, sir? Yeah. And I'm speaking about this deployment, I'm speaking about around 20 years ago scenario. Yeah. Right. Now, in this, what are pros of this approach? So I'll call this as generation 1, which is physical server deployment. I'm not even interested in pros. Pros is, it is simple. You have closer control. Okay, yeah, you can visit servers and do whatever you want. Let me try to speak about cons. So what is it we are trying to do? We are trying to have ineffective capex. Capex stands for capital expenditure. This means investment. Okay. Right, because I am calling it as ineffective. The basic reason is, if I have purchased a huge server, even though my application is taking less, I can't do anything about it. I can't reuse that system to something else. Okay, it is sheer waste of stuff. Right, that is the biggest problem over here. Okay, right, and generally, let me try to only speak about this perspective. I have ineffective capex. Why? And then because my resource utilization is mostly under usage. In some cases it is over usage. Even in that case, we can't do anything. Okay, right? Because we have bought the server. Then what has happened is, then something wonderful has happened. Okay. How many of you know this? VMware. Okay, right. So ideally I'm calling it as VMware, but the technical name for that is hypervisors. Okay, then what has happened in the computing industry is something called as hypervisors happened. The basic concept of hypervisor is, okay, you have a physical server. Okay, right. So on physical server, what is it I can do? I can try to run actually one application, or for one need I can use it. So on this, what I'll try to do is, I'll try to install hypervisor operating system. So this is a first generation hypervisor. Okay, and then I'll try to speak about a second generation one also. Okay, so what is it you're trying to take? You're trying to take physical server, and on that you are trying to create a hypervisor operating system. So in this world, we use something called as VMware ESXi. ఈ రోజుకి చాలా పాపులర్ ఇది. Sir, using bare metal hypervisor. Yeah, so this is the first generation one. So you install this. Now what this operating system does right now is, okay, to run, okay, for example, what is required to run an operating system? Majorly, if I try to speak, I need CPU, I need RAM, I need a disk, because my operating system will be stored inside the disk, and probably I might need some other components. So what this hypervisor has said is, I will try to give you something called as virtual machine. What is it, sir? Virtual machine. So on one physical server, what you can do is, you can create multiple virtual machines. So for each of this virtual machine also will get a CPU, no doubt about it. But here you get a physical CPU, and from this physical CPU, some amount is allocated to it that acts as a virtual CPU. And then in this machines also, you would definitely have RAM. Okay, but you will not have direct access to physical RAM. So this hypervisor OS will give you a virtual RAM. This physical server will have a disk. So from that, it will take some space, and then it will try to create a virtual hard disk for you. And in this virtual hard disk, you have an Ubuntu operating system. Okay, so whenever I switch on the system, what would happen? I get a machine in which Ubuntu is basically present. And not only this, what this hypervisor also does is, it tries to create something called as virtual network, and to that virtual network, this virtual machine will be created. So this gets an IP address which you can access from outside. Okay, so right now, rather than running my application on a physical server, the option which I have is, I can try to run them on virtual machines. Now in this case, what would happen? Initially, when I start to run the college application, for this I'll give one virtual CPU and 4 GB of RAM. Okay, if that is not enough, then I can add, because on my physical server I still have space. Not only that, I can add some other virtual machines so that I can effectively use the underlying hardware. Okay, so ఇప్పుడు ఇక్కడ ఏం జరుగుతుంది, డైరెక్ట్ గా ఫిజికల్ సర్వర్ మీద మన అప్లికేషన్ డిప్లాయ్ చేయట్లా. సో हम लोग सीधा फिजिकल सर्वर पे एप्लीकेशन नहीं डिप्लॉय कर रहे, फिजिकल सर्वर पे हम लोग इंस्टॉल कर रहे हैं hypervisor, and that helps us in creating virtual machines. And while creating this virtual machine, you can basically specify what is the amount of size machines which you want and all that stuff. Okay, and now in this is where your application runs, and hypervisor gives you an option so that you can expose this to the outside world. Now what I'll do is, okay, this came into play. Okay, so here we were trying to run on what? Physical servers, and here I'm trying to basically speak about virtual machines. Okay. Let me also speak about hypervisor or the second generation hypervisor. In second generation hypervisor, what you can do is you install whatever your normal operating system is, Windows or Linux. Okay. So on this, you install hypervisor. And this hypervisor will help you in creating virtual machines. This is the second generation. You don't need to have a special operating system. You can install this as a software on existing operating systems. If you are using anything which is Windows Windows 10 non-home editions, you will have this software which you can enable, which is called as hypervisor. Now on this, what I can do is I can create a what? In my laptop, I can create a new virtual machine and I can install any virtual machine of my choice. Okay. And while creating this virtual machine, okay, are you saying it is asking for memory? It is asking me to configure networking, virtual disk. Yeah. This exists in your systems already. Okay. If not, you can enable it, but on home editions, it will not work. But if you want a free alternative of this, there is something called as VirtualBox, which you can install. This is free, lightweight. VMware Fusion. Even a desktop may install this. Yeah. So VMware Fusion is basically something which I can install on my Windows 10 system, and it can help me in creating multiple operating systems. That is the second generation. But since we speak about servers, I want to stick to the first generation, because even today in data centers, companies prefer using the Gen 1 for servers and Gen 2 for desktops. Okay. Right, sir. Hypervisor is the actual component's name. VMware is a product. Just like operating system is concept and Windows is a product, right? That's a relation between hypervisor and VMware. Okay. So are we clear on this now? So now we have the concept called as hypervisors. Okay. With hypervisors, now we can create virtual machines. Okay. Or we can create multiple virtual machines from a single physical server. Okay. So are we clear on this, sir? Okay, good. Fine then. Now let us go to your college's hardware. Now what I'll do is, okay, right. Let me remove all of this. Okay. In my college, I have one server or two servers. Using that, what is it I'll try to create, sir? I'll try to create a virtual machine. Okay. And now what is an advantage of virtual machine? Now I can set whatever amount of CPU or RAM which I want, but the physical server needs to have available space. So I'm trying to run these two in a virtual machine. Okay. During admissions time, I have a lot of work. Okay. Now what I can do is I can try to run my application in two virtual machines at that point of time, and then I'll bring it back to one. So these kinds of things become possible. In the earlier case, if you have installed it on a physical server, the only option is if you want one more, buy one more. Okay. So right now I have a lot of free space that is present on the machine. So what I can do is I can run my extra applications, or I can scale these applications. Yes or no, sir? Right? So which is better, running on physical servers or virtual machines? This taken to the extreme level is what cloud is. So what is happening in the cloud? Cloud is basically where AWS and Azure are having their own hypervisors. They have the physical servers. You ask for machines, they are creating these machines and giving it to you. Okay. So the concept of cloud, the parent reason for that is hypervisor. Without hypervisors, cloud doesn't work, because cloud is always giving you virtual assets. Are we clear on this so far? So do you think this is better? Yes. Okay. Now this is my second generation. Okay. So life is good. All right. Let me go back to the question. Why did we start doing all of this? Because my college wanted a software or an application to be deployed. What is the focus, sir? మన మెయిన్ ఉద్దేశం ఏంటి ఇందులో? అప్లికేషన్ రన్ చేసుకోవడం. The main intent over here is to run an application. अपना बेसिकल इंटेंशन, जिस इंटेंशन से हमने ये काम स्टार्ट किया था, तो वो था कॉलेज मैनेजमेंट सिस्टम को चलाना. लेकिन हम कहाँ उलझ गए? सर्वर्स, physical servers, capacity planning, yeah. And now if you try to look at a skill set, if I'm trying to speak about physical servers, right, virtual servers, I need admins, I need database administrators, and we basically got track of yeah, what we should be worrying about is what are the features that should go here. As a company, I'll be interested in what are the features that will be part of my college management system. Can I build some recommendation systems? Can I build that so that I can start selling more? This is what I should be focusing. But majority of my focus goes on this problem. And not only this, for the people who have worked in what do you call, if you're working right now, I'm quite sure that whenever you testers raise a defect saying that this is not working, developers response is it is working in my system. Okay, this is a very common stuff. Okay, right, sir. Now let me try to tell you what the problem is. My intention is to run this application. Okay, so this application requires one virtual CPU and 8 GB of RAM. This application run cheyadam em kavali naku? One virtual CPU and 8 GB of RAM, and it requires a storage of approximately 1 GB or something like that. So can I give exactly same of that to this? Na application run avvadaniki one virtual CPU and 8 GB of RAM, and I need 1 GB of disk space. Can I exactly give that much over here or something closer to that? No. I have to also consider operating system. I have to consider all the other administrative tools that are present inside this. So my intention was running this, but somehow I'm running operating systems. Okay, this was not liked by majority of the people. Okay, right. So then what has happened is generation 3 has started. But let me try to speak about some other problems also. Fine, sir. So your company was running on a VMware. Okay, now your company, for VMware you need to purchase a license. Okay, now they have moved to some open source hypervisor like KVM. Can they directly reuse? ఒక సాఫ్ట్వేర్ వర్షన్ నుండి ఒక ప్రొడక్ట్ నుండి ఇంకో ప్రొడక్ట్కి వెళ్ళినప్పుడు డైరెక్ట్ గా మూవ్ అయిపోవచ్చా? రైట్, can they move from one vendor to other vendor straight away? No, it's not straight away. Okay, the first problem which I want to solve is portability. I want to run my application in such a way that it runs anywhere wherever I want. As a software company, that is what I want, because today I'm running on a physical server, tomorrow I might run on a virtual machine, day after tomorrow I might want to run on a cloud, tomorrow I might want to run in a washing machine. So I want my software product to be portable. This is the first thing. And the second thing is I want to give utmost respect to my application, not to the underlying components which run my application. Yes, these are the two design principles which we should always focus on. What is the first one? Portability. What is the second one? Right, most focus to application. Right, and in addition to that, it has solved many other problems, but let me try to speak about what this technology is all about. Okay, whatever technology which I'm trying to speak right now, it was there in Linux from early 2000s. Okay, right, but what has happened is it was very difficult. Only few companies were using that. For example, Google used to use that, Yahoo used to use that. But for using this technology, you had to be a very strong developer who understands low level Linux program. Okay, right. So during that time, there was a company which was called as .cloud. Okay, So what this company was trying to do was, this company was trying to basically build a platform as a service. So they want to build a platform where developers can directly deploy their applications and run it anywhere. Let it be on AWS, Azure, or physical server. They want to run it everywhere. So that's the product which this company was building on, a San Francisco based startup. So now for this company to run this infrastructure, what they have done is they have built a software. Okay. So what that software does is, okay, or what the software is called as is, that software is called as Docker. Okay. I'll try to tell about how it works later, but they have built something called as Docker. What is the company's name? .cloud. So what did they build? Docker. Docker was not their product. It was a subsidiary product. And what they have done is they have made it open source. They have made it open source. And it has become an overnight success. Because what Docker has done is, that underlying technology, which I was trying to tell was very difficult, only few top giants like Google were able to use it. It has democratized that idea. Now, I might not be an expert, but what I can do is, using this product, I can easily create the technology which is called as a container technology. అంటే డాకర్ కంటైనర్ ని క్రియేట్ చేయాల, సింప్లిఫై చేసింది. డాకర్ ని కంటైనర్ को क्रिएट नहीं किया, उसने सिंप्लीफाई किया. Now you and me in 2 or 3 days will be able to basically run our applications inside containers, scale them. Okay, but earlier that was not that simple. It was very difficult. You had to write a low level Linux code to achieve all of this. Okay, fine sir. Now exactly in few days from that moment, this company got disappeared, and just because of this product, the company's name was renamed to Docker Inc. వాళ్ళు మొదలుపెట్టిన కంపెనీ పేరేంటి? Now no one knows who .cloud is, but everyone knows what a Docker is. And these guys gained lots of investment from various sources. At that point of time, when Docker was coming up, it used to work only on Linux. But during that time, Microsoft was working on Windows 10 and Windows Server 2016. They had to release their product. By looking at this, what Microsoft has done is, Microsoft has sent some engineers to Docker. They have created a partnership, and they have made this technology natively work on Windows. So now on a Windows operating system also Docker works, that too natively. Okay, right? So this is what has become the most what you call happening thing around that time frame. Okay, right. So now all of this historical facts is fine, but what does container do? Let us try to understand that. Okay, if I shut down one VM, other VMs along with that, will it affect other VMs? సార్ అపార్ట్మెంట్ లో ఫ్లాట్లు ఉంటాయి సార్, ఒక ఫ్లాట్ కి తలిపేస్తే మిగతా కూడా ఎఫెక్ట్ అవుతాయా? దగ్గర వర్చువల్ మెషిన్లు కూడా అంతే. ఓకే, కానీ భూకంపం మొత్తం అన్ని ఫ్లాట్లు పోతాయి కదా. సో ఫిజికల్ సర్వర్ పోతే అన్ని పోతాయి. That is how you need to relate. Okay, fine then. So now what is this container technology? At its very core, first thing is the software that runs is not only the technologies, but I'll be using Docker because it's the most popular. You can install Docker on a physical server. You can install it on a virtual machine. Okay, right. ఇందాక నుండి వాడిన లోగోనే వాడదాం. Okay, and you can install Docker even in very small electronic devices also. Okay, it needs a basic operating system. So where can Docker be installed? Yeah, so on a basic note, what it needs is, it needs either a Windows or Linux or a Mac system on which it would run. Whether it is a physical server or a virtual server, it doesn't matter. Am I clear on this? So while we were creating this virtual machine, what did we do? We gave CPU, we gave RAM, and we run our application inside this. And for the application which is inside the virtual machine, it has operating system, it has physical server. I mean, it has CPU, it has RAM, right? It has everything for the application to believe that it is running in a normal server and it runs. Okay. Now, but for example, the way virtual machine works is, let us assume that if I have 80 GB of RAM. Okay. Oh, shit. Now RAM size and sir 80 GB. While creating this machine for this RAM, let us assume that I have given 78 GB. Okay, I'm left only with 2 GB. That's how it works. So once you assign this, decisions are taken by whom? Yeah. So here, let me try to speak about this concept. This is called as host OS. This is called as guest OS. Am I clear on this, sir? So what is host OS doing? Giving all the necessary resources to the guest OS, and guest OS will make its own decisions. Okay, so for that reason, this operating system becomes an extremely important concept over here. But this is exactly what these guys didn't like. Okay, so now in the container technology, what happens is, you take a physical server or a virtual server, you install Docker. So underlyingly, what is that you have? You have a Windows operating system, and you have a Linux operating system. What this technology does is, it creates something which is called as container. What is it, sir? Container. Okay. Now, this container also gets virtual CPU, virtual RAM, and virtual network. But there are some subtle differences. Inside the container, I will generally not have a full-blown operating system. I have a very lightweight operating system. Okay. On this machine, let me try to install Notepad+. Open Notepad++. When I open Notepad++, what would happen, sir? An application like this will be opened. And now if you open Task Manager, come on. Okay, మీరు ఏ application open చేసినా, right? Are you saying there is some amount of CPU and RAM that is given? Okay. Now in the case of virtual machine, the CPU and RAM is basically allocated to it. And if it needs more, this operating system makes a decision. So this operating system is a critical role over here. And in the container technology, what happens is, to make critical decisions, this container technology will not directly take it. It will try to redirect all of that to the Docker, which speaks with operating systems. So majority of the decisions are still taken by your host operating system, not a guest operating system. Guest operating system is still inside the container, just to make believe that your application is running inside the similar environment. But this is a very lightweight operating system. This is a very, very lightweight operating system. Okay. Now, the other part, this I can run anywhere. I said that, right? Physical server, virtual machine, take it to any cloud, right? You can run it inside air conditioners also. All you need to have is, you need to have this container technology installed. Extremely portable. Okay. So this is what Docker has done. And this concept was there in Linux from long back. It was called as LXC, Linux containers. Okay. But the point is, Docker had made it simple. Are we clear on this, sir? Yes. Now, I will have my application running inside this container, and my container's full attention is to run one process, and that one process is basically your application. So inside this, the topmost priority is given to what? Not to operating system components, but to your application. Okay. So this is the third generation. This is the third generation. Now let me try to give you an example. Okay, before trying to get into the detailed part. So what has been changing from here to here is now we are relying on a container technology, which makes we are becoming slimmer. That's it. That's the whole idea. So initially to run my application, I had to have a physical server. From there, I moved to virtual machines. Okay, right. So now let me try to show something, sir. Okay, generation 3 is container. Still now I have not defined what a container is. I have roughly given you an idea of what a container is. But let me try to give a rough analogy. Container gives an isolated space for the applications to run. అంటే అప్లికేషన్స్ రన్ చేయడానికి కావాల్సిన ప్రైవేట్ స్పేస్ ని కంటైనర్ ఇస్తుంది. దిస్ ఇస్ ద హోల్ పాయింట్. ఓకే, నౌ అట్ దిస్ మూమెంట్ we will try to discuss a little bit deeper into this, but let me try to show you something. So okay, cd on my system I have Docker installed. Okay, there is no need for you to do this, just understand this stuff. Okay, and I am against installing Docker on laptops. Okay, as a DevOps engineer I need not do it. If you are a developer, do it. Okay, so I've been developing some application, that's the reason why it is present on my system. Okay, fine, sir. So what I want to basically show is I was building some application for some demonstration, which was called as library management system. Not fully functional, but it is library management system. The way this application works is it has 3 components. Any component only, sir? 3 components. And it requires 2 databases. Okay, right. So one component is users or identity service. Okay, now what is this users or identity service? Just like how you in Google you create authentication, right? So I have created a Google account. So in the same way, in my library, librarians, the consumers, admins, they basically create account inside this. Okay, and this is my library component. Okay, so this is a library service. So in this library service, it maintains what are the books that are available, how many books do we have. Okay, renting out, returning back, this kind of functionality is implemented. So this is developed in Python. This is developed in Python. This is a Postgres database. This is a Postgres database. And right now I have one more application which is called as, which is basically front-end application, which is developed in React.js. So what users will do is, users don't know all the underlying components. They basically go to the Chrome, and when they access the URL, UI will be given by React.js. All the business logic, React.js application speaks with either this service or this service. Ideal ga నాకు ఇది రన్ చేయడానికి ఎన్ని సర్వర్లు కావాలి? I'm speaking about 5 servers. 5 na? Yeah. So running this on one server, running this on one, this on one, this on one, and this. So totally I'm speaking about 5 servers. Now let us assume that I make it hosted on the internet. Then what would happen? As the number of users increase, so I need to increase number of servers. ఒప్పుకుంటారా దాన్ని? Yeah. So right now this is the application which I have built. Okay, now right now this application, this is developed in Python. This is developed in Python. This is developed in React.js. Now to deploy it, I am trying to speak about 5 different operating systems, right? Okay. I need to do some cleanup. This is containers only, right? Yeah. Okay, sir. these kind of activities will be given to you in that practical DevOps stuff, where you will be given the code of this application and asked you to build the Docker applications, because this is what you do in reality. Okay. Now in this, I think I have library management system, and let me try to open the whole code. So this is what I was trying to speak about. As it, you need not understand code, sir, but what I'm trying to tell is your developers have written books, users, and then there is a front end. And for installing this, how many softwares do I need to install on my system? Too many, right? Okay. And now let me try to show you what I do. I try to run all of this application by executing docker compose up hyphen. Okay. So how many components did I spoke about? 5, right? 2 databases and 2 services and 1 front end component. Okay. So for the people who have attended yesterday's demo, I think I've said that we need to learn how to build Docker packages. Yes. So for building applications which are running inside Docker, what we do is we create Docker packages. The Docker package is called as Docker images. Okay. So right now, if you go to the images, are you seeing it has built the images? Yes. Okay. Right. This Node.js application takes a little bit of extra time because I have not optimized it because I want you guys to do the optimizations. Yeah. So how I did it, well, don't worry about it. That is what you are going to learn. But just try to understand. All I have done is executed one simple command, and internally it is basically creating how many stuffs. It has not launched yet because it has to create all of this. This has to finish. Okay. Now what I can do is I can take this application, run it on AWS, run it on Azure, run it in Google Cloud. It doesn't matter. Once I have image, I can take that image and run it anywhere. Okay. Right. And even on these devices. Yeah. So you buy that. Inside that, you will have very lightweight Linux operating system, and try to run your application inside these devices. And this will have a very small Ethernet port connected to that. That's it, done. It will give you a shell. ఇలాంటి కూడా మీ అప్లికేషన్ రన్ చేసుకోవచ్చు. Yeah. This is popular. This area is popular for IoT applications, right? So whenever I have some kind of a device where I need to run some extra stuff, this is popular in those spaces. Okay. Whatever is composer at this moment, don't worry about the underlying technology. Just understand what is happening. Okay. I wanted 5 servers and I'm running it on my laptop. Yeah. What is this technology? For me, it would take at least 3 or 4 days for you to reach to this point where you understand these commands. So don't focus on commands. It doesn't matter, because tomorrow there might be a better software than Docker to do this. Yeah. The underlying concepts are important. So physical server to virtual machine to container. This is the transition which you need to basically understand. Oh man, I said that, right? This takes a little bit of time, but please be patient. This optimization will be something which you guys will be doing. Yeah. All right. So while this is happening, let me show you a sample architecture. నేను చేసిన చిన్న అప్లికేషన్ కదా. Let me try to show you what the reality looks like. Everything here, all of these are containers. This is the e-commerce application where every component which you are seeing in this box, all of these things are what? Containers. Okay, so you build these containers, somehow give it to Kubernetes, and then Kubernetes does the rest. This is how all the applications are basically working on. Okay, right. So ikkada meer chuse prati component container. Yeah, right, we are almost there. For running applications, even if I take the smallest of servers, okay, right, fine, sir. Let us see first of all what is happening. Your application is running, right? First let me try to show you the application. No. Are you saying now when I made the request, what did happen? It basically went to this front end application. Now if I basically click on login, I don't have any users right now, but it will start hitting with this. Once I log in and then basically click on books, then this will happen. Okay, right. So let me try to insert some dummy data. So on the dummy data insert చేద్దాం just for fun. Don't worry about these tools, sir. You need not have all of these tools. All you need to do is understand this evolution of applications. Good. Okay, sir. I have generated some dummy data. Now let me try to log in. Okay, so now the user service has said that you have successfully logged in. Now let me click on the books. Right now I have 3 books in my library. Okay, so this front end application is basically getting data from all of this, and the data is getting stored in 2 databases, all of them running on my system. But let us try to see what is the memory which they are using. So you can basically try to look into it. So what is the memory which they are consuming, sir? 33 MB, 72 MB, 65 MB, 35, 33. And what is the CPU? 0.16, 0.15. Is it large or less? So on one physical machine now, can I run many applications now? So is it not the utilization of hardware? Yes or no? Right? So this is where Docker becomes extremely cost optimized version, and for basically building those images, zero charge. Okay, my application basically is running on a zero charged container. Okay, because I am not paying any license fee for the operating system licenses inside containers. Okay, so let me go back over here. If you are running virtual machines, and inside this virtual machine, if I am running Windows, do I or don't I need to pay the license? Windows Server license cost untunda undada? Red Hat kuda license cost. So, but as for example, if I'm trying to build in container technology, I don't pay any license for containers. For operating systems inside containers. So one physical server, probably I might try to take one Windows license or one Red Hat license, not for every image that basically runs. I'm speaking about cost optimization also. Speaking about cost optimization and effective utilization of your freely available hardware, and it doesn't expect fancy hardware. Whatever it is available, it will try to run the application over there. So this is what the container technology does. So what is container making it? Extremely portable. Okay, why am I calling it as extremely portable? Right? So I've run my application on this machine, right? And in this, if you try to see, all I need is to run this container, I need something called as images. I'm not speaking about all the images over here. Are you seeing at this image which is called as Postgres? Is in build cheyala. This is not something which I have created, right? So there are lots of images which are already built, which you can take and run anywhere. So when I want a Postgres database, I'll try to take this image. I want to run a Apache server. So then what will I try to do? I'll try to search for. Are you getting Apache server? Yes. Okay. Right, sir. This is one part. Now, if I want to run a Linux on virtual machine, what will be the minimum size of the disk? And general size anta undochu. I am trying to speak about a lightweight Linux. 1-2 GB aithe untadi kada. Yeah. Let me show you something interesting. This is Alpine is also one flavor of Linux. What is the size of it? I can run my application on a Linux whose size is 7.8 MB. That means that inside this image, I'll have only what is necessary for my application to run. So we are getting into lightweight stuffs and we are basically getting into scalable stuffs. So did you understood these three evolutions? Okay, I need to speak a lot about containers, but I want to make you understand three generations. What was the first generation? Running everything on a physical server. That is extremely waste in terms of cost, because I might have a very hefty server on which I'm literally doing nothing. Then we have spoken about virtual machines. It is good technology. Even till today, there is no doubt that it is a good technology. But the only problem with that is I give more focus on operating system rather than an application. But once I'm speaking about container technologies, all I need to do is build this image and share this image wherever I want to run the application. And container also makes my application very effective. And it runs by giving complete attention to my application. Okay. So inside the container, if some operating system was basically utilizing resources, do you agree that is it possible to run an operating system with 33 MB RAM? 33 MB RAM lo operating system kuda run avutta kudurudda avada, right? So on an Android operating system, on a smartphone, we are using 12 GB of RAM. Now I'm trying to speak about an application which can take requests from the user to insert books into the database is taking 33 MB of RAM. Yeah. So this is extreme optimization. Yeah. And it cut down your cost, and it takes or it puts forward new ideas for discussion into architecture. That new idea is something which I'll try to discuss in the next session. Three generations. Are we clear? Yes. Physical server running in virtual machine. Third one in extremely lightweight container. But even today, I have not dissected the container. I have not spoken about what this container is. I've just shown you. I want to run 5 different servers. I'm running all of that with the help of one single command. So tomorrow we'll dive a little bit more deeper into this and try to dissect the concept of container a little bit more. Clear on this, sir? And there is no need for you to install any of this on your system. I'll try to speak when you have to start installing. Okay. So generation 3 is container. Tomorrow we'll try to dive. Today we have seen 10,000 feet of containers. Tomorrow we'll try to dive a little bit deeper into that. Okay. Good, sir. Okay, sir. Any questions on whatever we have discussed today? Are there any questions? Okay, sir. So kindly stay back. I'll be sharing the classroom notes URL, and then you can basically log off the session. So what is our first responsibility now, sir? Whatever application that your developer is developing, I need to make it run inside the container. That's my first responsibility. Once we understand that, then how can I scale it? The next things come later. So first step is understanding this containers and making your application run inside the containers. Deeniki technical pere containerization. And in your resume, you would be writing something like, I have hands-on experience in containerizing, okay, or Dockerizing applications. But basic idea is making your application run inside the container. Okay. Right, sir. Even the problem which you need to address over here is today. I expect you to only understand 3 things. Just tell me, even if you come from a non-technical background, did you understood physical server, virtual machine, and there is something called as container, which makes the life simple by reducing costs. ఎంతవరకు అయితే అర్థమైందండి సోమేష్ రెడ్డి గారు? That's it. That's the only takeaway from today's class. Okay. Tomorrow we'll try to dive a little bit deeper. Yeah. Okay. Fine, sir. So the note should be uploaded in directdevops.blog. And this is the classroom notes which I have written for today. Yeah. So it is available for over there. Kindly have a look at that notes. Right, sir. Okay then. Thank you. Thank you all for attending. We'll meet again same time tomorrow. And till we understand basically the concepts, if there is any terms that come your way, kindly make a note of those terms. Today, I think I've tried to be maximum non-technical terms I've tried to use. The only term which I might have used today is hypervisor, and I have defined what a hypervisor is. Okay, but still, if there is something which terms which come your way, kindly make a note of them, search them, and if you don't understand them, you can obviously ask me. Yeah, right, sir. Yes, sir. Go ahead. Balram Reddy, I see hi, sir, from you. Is there anything which you want to speak with me? Okay, yeah. The thing which I want to basically tell to the online students is you will be on mute during the session. If there is any doubt which you have, you can type me in the question section, and I will try to unmute you based on the necessity basis, because I can't give control to you people to unmute yourself, because we have done that in the past, and we have I don't have any problem with that, because for the people, you will get the recording of this, and in the recording you will be trying to come across very strange noises which I don't want. Okay, or not me, others don't appreciate. So that's the reason. Okay. Now I have unmuted you, sir. You can unmute and speak. If you have any doubt, then ask me, then I'll unmute. Okay. So where can we see the recorded video? So you will receive an email where you can see the video, sir. Okay.
Hi, sir. Is it Kale, sir?
Yes, sir.
Sir, one of my friend has given reference this training. That's why I
Yeah.
like to join.
Right.
But just how can I interact with you, sir? If I get any doubt, you're explaining all the server setups, everything.
Sir, the point which you need to understand is I can't acknowledge every doubt which you get immediately. After the class is done, make a note of your doubts and then you can ask me, then I'll try to resolve. Am I clear on this, sir? మీకు వచ్చిన వెంటనే ఆన్సర్ చేయాలంటే నేను 230 మంది ఉన్నారండి ఆన్లైన్లో. ఓకే, my class will go in doubts itself, so make a note of them, and after the topics are finished, then just like how do you did ask today, you can ask me the doubts.
Okay, got it, sir. But yeah, okay, sir. అదేలేండి, నాకు ఇక్కడ ఏం అర్థం కావట్లేదు. ఇది మీరు ఎక్స్ప్లెయిన్ చేశారంత అంత గ్రాఫికల్ గా ఉంది. మళ్ళీ సెటప్
సార్ మీరు ఇప్పుడు ఏం చేస్తున్నారు? ఇంతకు ముందు ఇప్పుడు ప్రెజెంట్ వాట్ ఇస్ ఇట్ యు ఆర్ డూయింగ్ రైట్ నౌ?
నేను టెస్ట్ ఇంజనీర్ అండి. సో టెస్టింగ్ చేస్తాను సైడ్. సో ఐడియా మీరు చెప్పినంత అర్థమవుతుంది, కానీ ఇంప్లిమెంటేషన్ యాడ్ అనేది నాకు అసలు దాంట్లో ఏమి తెలియదు.
సార్ నిన్నటి వీడియో చూసారా మీరు?
నేను చూడలేదు సార్. నిన్న
మీరు నాటికి సగంలోకి వచ్చి అత్తగారు ఏంటంటే ఎలా ఉన్నారు, ఎర్రచీర ఎందుకు కట్టుకున్నారు అన్నట్టు ఉంది మీరు చెప్పింది. సో జస్ట్ గో త్రూ ద యెస్టర్డేస్ వీడియో, యూ విల్ హ్యావ్ ఎ కంటెక్స్ట్, అండ్ దెన్ టుడే వీఆర్ ఇంట్రడ్యూసింగ్ 3 different generations of running applications. That's it. Inte context. Okay. The practical context, I can't speak about the whole of DevOps in one day, right?
No. I'm not asking like that, sir. Just naku akkada
don't get offended. What I'm trying to tell is there is a context of in yesterday's class which you have missed. Kindly go through that. And today's session you just listen to it. And because today's concept is only 3 generations of running applications. That's it.
Okay.
Yeah. Right.
Okay, sir.
Fine then. So there is one question saying that is containers like write once and run anywhere? Absolutely, sir. Okay. You create your Docker image once and run it anywhere. That's true, Ashwini. Right.
Sir.
Yes.
सर यहाँ पर क्वेश्चन जो आप पूछ रहे थे कि बोले थे कि क्वेश्चन पे हम पूछ सकते हैं, लेकिन यहाँ पर क्वेश्चन अंदर क्वेश्चन तो नहीं है, मतलब जहाँ पर हम बोल सकते हैं कि हमारा ये डाउट।
मोबाइल में लॉगिन हुए हो मैडम आप?
क्या सर?
मोबाइल में लॉगिन हुए हो क्या?
नहीं, लैपटॉप में।
लैपटॉप में हो तो क्वेश्चन सेक्शन दिखना चाहिए मैडम। एक काम करो, आपका जो स्क्रीनशॉट है ना, वो निकाल के एक बार क्वालिटी थॉट के मेल पे भेज दो, राइट? बिकॉज जनरली व्हेन यू कनेक्ट फ्रॉम मोबाइल फ्रॉम योर सिस्टम बाय इंस्टॉलिंग गो टू वेबिनार, यू शुड सी ए क्वेश्चन सेक्शन. चलो क्वेश्चंस नहीं दिख रहा है तो चैट तो दिख रहा होगा ना?
नहीं, चैट भी नहीं दिख रहा है.
चैट भी नहीं दिख रहा है. अच्छा ठीक है, आपका स्क्रीनशॉट भेज दो, देखते हैं क्या गलती है उसमें.
और एक क्वेश्चन,
there is actually arrow mark which need to be expanded, then only she can see, sir. Actually,
which needs to be expanded?
The arrow mark, red color arrow mark.
Re-arrow. Okay.
Yeah.
On the right hand side, there is a on the top right hand corner. You can see one arrow. If you can expand and you can minimize that one. Okay. If you expand, you can see the question and the answers, ma'am.
Okay. So what is the difference between Docker and a container? Docker and a container, the difference is like operating system and Windows. Container is a concept, and that has been realized by a software which is called as Docker. Just like an operating system is basically a concept which Linux and Windows have realized, right? That's the relation. Okay, sir. So the notes is uploaded, and we'll meet again tomorrow. Yeah, and let us try to see how. हाँ बोलो मैडम.
हाँ सर, और एक क्वेश्चन की जैसे आप करते करते विजुअल स्टूडियो कोड में किए, मतलब आज तो कुछ किए नहीं थे.
कुछ नहीं करना मैडम. मैं क्लास में क्या करता हूँ ना, नोट्स भी मैं ही लिखता हूँ. ओके.
अच्छा.
तुम नोट्स जब मैं लिखता हूँ कहीं ना कहीं तो लिखना होगा ना, इसीलिए विजुअल स्टूडियो कोड यूज करो. आज आपको कोई भी सॉफ्टवेयर इंस्टॉल करने की जरूरत नहीं. जब जरूरत है मैं खुद बता दूंगा.
ठीक है.
Okay then. So I'll stop it at that. We'll meet again tomorrow. Thank you.